Hello. Hello, Pankaj sir.
Hello.
Yes, sir. We'll start in 10 minutes.
Okay, Ganesh, no worries.
Thank you.
Hello Ganesh, is my voice clear?
Yes, clear.
Okay, thank you. Okay, we will start in 2 minutes. Let all the participants join. Okay, just anyone can tell me that I am clear.
Yes, ma'am.
Okay, so we will start now. So good afternoon to all the participants and our speaker for today, Mr. Pankaj Sharma. So firstly, congratulations to all the participants who have cleared the round one of Sparkathon. Okay, so I know that all the participants are excited for the results today and they are eagerly waiting. So the results will be announced soon. But for now, let's continue with this webinar, and this will definitely help you all in the final round. So, firstly, all of you all know what is Sparkathon, what is it about. So, Sparkathon is a 24-hour national level hackathon organized by CerebroSpark Innovations in association with JSPM Jayawantharao Sawant College of Engineering, Pune. So the main motto of arranging this hackathon was that to provide engineers a technical or incubation or a mentorship support. So the hackathon is conducted and it will really be beneficial for you all, like the participants, from learning to like converting their concepts to prototype. So for this, we have our technical partners with us, the IIC Institutions Innovation Council, IEEE Education Society, IEEE Pune Section, Pune Management Association, IP Lab, Aspire Technology, and for AI support, we have Automation AI. And for the incubation partner, if anyone wants to convert their project to a startup, so we have our incubation partners, AIC MIT ADT Incubator Forum, Pimpri Chinchwad Startup Incubation Center, and Welltech Incubator Forum, Chennai. So all the teams will get a lot of opportunities, but for now, let's continue for what we are here for. So we have Mr. Pankaj Sharma with us, our speaker for today. He is the head of Makers Lab Tech Mahindra. He has a great experience of 30 years in the IT industry and he's currently working in the robotics domain, creating a CKD robotics kit for all the students. So I think this webinar will definitely help you all learning something related to robotics today. So after which you will get to know your results. So be tuned, be concentrated, and keep your ears open. Yes, sir. Now I hand over to Mr. Pankaj Sharma.
Thank you, ma'am. So, hello, everyone. Good afternoon. And first of all, best wishes for the Republic Day today. And good to see so many participants. I see almost 50 plus participants here. So that's very encouraging. Today, what I'll do is I'll talk about robotics in a very, very generic way. And going down the line as the hackathon progresses, probably we'll have more focus sessions as well. Everyone can hear me, right?
Yes, sir.
Right. Let me put up my screen. So it's going to be a very, very generic presentation talking about robotics from the concept of, when it initiated to till date, what we are seeing, what we are progressing. That's something, robotics has always been considered to be something, something which is, future looking. It's a forward looking kind of a facet of science, right? About me, you've already heard. So it's been 30 years in this industry now. I had the Makers Lab at Pune. I'm the SME for IoT, drones, and robotics over there. And have worked on SCADA automation projects as well, and have been interested in, always doing something which would do some kind of a control, some kind of a manipulation. And that's what slowly moved me into robotics as well. So let's begin, and we'll talk in the next 30, 40 minutes or so. When we'll talk about what transpired and how these things came up, right? So humans have been fascinated by the robotic idea since long, long ago. Leonardo da Vinci in 1495, he developed a mechanical knight. The structure is there, and the good part is his creation actually do work to a certain extent. His ideas were always practical, and he thought, probably humanoid kind of, interfaces would be there where something would move much like a human. Okay. And that this is now, think of it, it's going into 1495 sort of. But if you look at the first industrial robot, it was called Unimate, and that was installed way back in 1961. But if you look at today in 2021, it is estimated that there are about almost 4 million kind of industrial robots available. 3788, thousand as of now. But typically, so these robots are now placed in industries, and they are actually producing. They are actually generating some value out of the creation which has been done. So the question is, why robots? What lures you into robots? And there would be many of your, out of these participants that I see, there would be many who would have built some robots. Many of you would have seen robots. Many would be intrigued and, done something on that, but have not actually implemented something. This forum is a good forum where I can talk about it, tell you what can be done with these robots and what you can build upon. So for that, you need to understand what a robot is. You need to understand what qualifies, if I build a small device like a scooter, does it qualify to be called a robot? Right? No. A robot essentially is a machine which can be programmed, number one. So this is the primary criteria. The object or the device should be programmable, and which should be able to carry a series of actions. There has to be a sequential series of actions which can take place. And generally, these are complex actions. And then it constitutes a robot. If I cannot program it, for example, a scooter, I don't program it. I just, use a scooter as an automatic device or maybe a mechanical device. There's no programming as such. Number two, I cannot tell it to actually do a series of events that, okay, go to the market, fetch me this product or thing. That is not possible. When that is not possible, then it does not qualify to be called a robot. Right? Another aspect which is there is that the robot has to be a moving object. It cannot be a stationary thing which is just sitting there. So a radio on your, table, this laptop, they don't qualify for a robotic structure because there's no movement. There's no physical construct which is changing over there. At the same time, if you look at a fan, it is moving there. There's some locomotion there, but then the fan is not programmable and it is not doing a series of operations. So this is what essentially constitutes the robotic definition. So robots can be a complex autonomous industrial robotic arm, or it can be a simple, toy car which can move around a fixed navigation. Even that small toy car which can be programmed would be called a robotic toy car. Does that make clear? Now the question is, why do we want to use robots? And this has been an age-old question, and there have been philanthropic and various kinds of thought processes, and people have given a lot of philosophies and a lot of theories behind this. But the reasons are based on the use cases. Multiple industries, multiple facets, multiple domains, they need different kinds of robots. If you go to the industrial side, on the manufacturing side, you need robotic arms to manufacture. to probably weld something, to inspect something, to clip something, to screw something, place something, pick, hold, sort. These would be industrial kind of things. On the other side, you could have robots which are humanoid in shape and which are running and which are fighting people. Then it becomes a defense statement where defense would need these robots. Robots in defense would be, for n number of reasons. Likewise, you would have robots which would work specifically for medical industry, for surgeries, for giving assistance to the doctors, for picking and carrying medicines and other services to to patients as a assistant or maybe a nursing staff. So that would be different kinds of robots. Based on the usage, you have almost like 16 different kinds of robots available in the market. Okay. And why do you use them? You principally use them for applications where you need some kind of a physical movement, as I said earlier. The most commonly used mobile robots today are drones, and these are actually robots because A, they have locomotion, B, they can be programmed, and they can have some kind of even an intelligence in them. So drones are now being actively used in military, in defense, in surveillance, in exploration. You would be surprised. One of the major usage of drones nowadays, apart from GIS and other surveys, is being done by insurance industry. So they are using drones very actively to look at assets, to look at physical locations where a surveyor cannot go, do some kind of an operation, get back the feedback, and then the insurance can be processed. A very unique case. Similarly, for oil exploration, for going out into the deep seas, figuring out. Now there are drones which are available, which can be submerged in water as well, and they can do surveillance both in air as well as in water. So you have amphibian drones available which do both these cases. So they fly on, they go back and then dive inside the sea, propel around, do some kind of recce, come back with a lot of data available. So this is happening, and this is why robots are very, very important. Think of it, you want to do a surveillance today in Bombay High. So look at the effect which would happen. You would probably have to ferry charter a boat, go to that location, then get into a gear or maybe a submarine or some kind of a metallic ferry device which can go inside the sea, take you over there, you conduct your operations over there and then come back. The same thing if it is done remotely where you are on the shore, it makes it much more safer, much more qualitative than you would probably do it yourself and risk. So risk mitigation is also one important criteria for all kinds of robotic endeavors that are happening. Most of these robots, they typically are used in controlled environments. As of date, we are not too keen to have robots which are completely autonomous out of n number of reasons. Lack of control over robots could lead to some kind of an accident or some kind of a risk. So that's the reason. But soon you'll see autonomous robots and self-thinking robots, and as AI progresses, that would change the whole paradigm. And I foresee that in the next 20, 30 years or so, you will see robots which would typically be able to do a lot more riskier kind of, expeditions than you today do it. All right. Robots are also being used for educational purposes. And not only you have robotic kits which can help students learn, but robots can themselves be teachers. There have been cases of, certain university, for example, in Boston University itself, there have been robots who have taken certain live classes and they've done a phenomenal job and the students actually liked it. So likewise, they can be teachers, they can be used in educational purposes. It can do a lot of stuff for students. and do kind of explorations as well. So this was back then, and now what is happening? Robots are now becoming an integral part of the society. Today, from domestic cleaning, right, to industrial robots, they are getting it. And you would not believe, but probably the robotic penetration is much, much faster than you can think of. In Mumbai alone, it is estimated there are about 15,000 to 50,000 robotic, different use cases of robots available and in use in Mumbai alone. And the speed at which the adoption is happening is mind-boggling. It's happening at almost like 36% CAGR. So every year you see 36 percent robots being increased. That's phenomenal. You might see in coming times that you would have complete platoons of almost like 100 to 300 robotic you know robotic fighters, or you could say soldiers, which would actually do a war kind of a scenario or some kind of a salvage operation to be conducted for the defense purposes. That's very, very near. The robots that you see in industry have taken up very, very effectively, and they are the most sought after right now because they make the mundane and the repetitive tasks of the industry very, very easy, and the risk factor is reduced. And India as of now is seeing a surge of robotic arms being deployed in all industries. Industry 4.0 is all about robots being deployed and the processes being automated on the industrial side. Most mass production assembly lines now, instead of humans, they are relying on robots to do the inspections. So whether the welding has been perfect or not, that is checked. B, even the welding which was performed was done by a robot, and the second robot is actually inspecting and seeing if the welding was done perfectly or not. All these indicate that the adoption of robots is happening at a phenomenal and a very, very synergic way in the whole society. Another aspect with this is robots per se would consume energy on one front, but they do not tire up, right? So you can actually have robots which can work for 24/7 if possible. If you have the need, you can make them work 24/7. That kind of a scenario gives a huge boost to production side. Today, when we are in a phase of pandemic, think of the robots being able to perform and make operations, giving these injections and making those vaccines. All these processes, if they are done by robots, the production speed can be increased to a phenomenal extent, which today is pretty much dependent on human labor. Should this happen in future when robots would be in there, the production of vaccines would speed up. The production and the deployment of vaccines would also be easier. Instead of nurses, there could be robotic hands, which do a minor, injection being given to your body and the patients. That could be taken up by these robotic arms and these endeavors. Similarly, if you look at the medical side of it, the production of a lot of medical robots is happening at a phenomenal rate. In Pune alone, there are about 15 to 20 different hospitals which have actually deployed robots. So some kind of a robotic surgery, which also allows you to do a remote surgery. So I can have somebody remotely sitting, say in US, a good doctor in US, who's needed to operate on a person, he can do it virtually over there. So from there, he operates on a dummy patient, and the same is replicated over here on a humanoid robotic arm actually conducting the surgery. So the precision increases, the quality increases, the resource usage optimizes in this case. Got it? And this is growing at a phenomenal pace, as I said, 36% CAGR, which is actually phenomenal. So now question comes up, how do you get into robotics? And that's something which I'll take more time on. With the popularity of internet and the increasing accessibility of knowledge, you get so many webinars, you get so many things, Udemy, and many other platforms, Coursera. Every important university today is giving a lot of knowledge on robots, and that's increasing. That's accessible to you. You can take lectures on there. You can learn about robotic operating systems. You can learn about making robots. You have things like Thingiverse and other where you can do actual designing as well. You would be able to create replicas out of them, build those replicas, present it to people, and make your own use cases, work on them. The three important aspects in primary robotics is one, the mechanical structure. So you should be having some skills on mechanical side. That's very important because you would learn how to design a robot with respect to the physical asset. How many arms, what degrees of freedom, what should move, how much should it move, will it traverse laterally, whether it's circular, whether it's a locomotion or it's a stationary thing. All these things would require good understanding of mechanical engineering. And you can acquire these skills. If you don't have, then you can probably acquire those skills. It's not very tough. But important part is you should have basics of mechanics where you understand what mechanical advantage is. You understand what velocity ratio is. How do you increase the torque? What kind of a motor has to be selected? All those parameters depend on the physical design of a robot. So we recently had a customer who's asking us to do a robot designing where we would use that robot to go around a specific area and do a physical surveillance of the area with respect to any security threats and to identify certain objects in that area. It could be plants, it could be, cars in that locality or whatever. Now, this small robotic thing requires us to build the physical aspect of the robot, right? We have to have a chassis. We have to have the motors inside them. We have to have the wheels. We also have to put the cameras and other electronics into it. So the second aspect comes here, which is electronics. So a good handle on electronics engineering, how electronics work, how motors are driven, power, current, voltage, these elements, how do you devise them, how do you make objects using these, and how do you design the entire electronic structure. Because eventually somewhere or the other, there will be actuators, motors, sensors, which would be deployed inside your robot. These sensors, these motors, they have to be actuated. They have to be run based on your programming command. As soon as that happens, the third facet comes up, which is the programming part. So software becomes an important element. Within the software stack, you should have good knowledge of web technologies because a lot of, the transport layer happens on HTTP or Bluetooth kind of things. So communication becomes important within the software stack that you would use. And then you would even have a lot of AI, machine learning for the robot to learn something. When autonomous, vehicles were started to be created, Google took the lead and they started using lidars to figure out ways. And they probably had the longest run endeavor on autonomous driving, and they relied completely on sensors and lidars. It took them almost 11 years or so, and still they have actually not really, and they've run almost like 100,000 kilometers plus. But despite this, their system has not been technically deployed in any vehicle as such. Whereas Tesla started much lesser and much after them, but they have been able to achieve actual car in production, Tesla, which has autonomous driving in it, and which has been done at a very, very lesser, period of time, and it does not use electronics sensors. It is completely vision based. So they just use cameras and artificial intelligence to control the vehicle. So you see the difference. The applied science of software, AI, machine learning, electronics, mechanical, they come together, and then you have the complete robotic structure available to you. These three elements, if you have any one of them, then you can acquire the other two, and that could, probably. Other than that, if you have only, one or two of these, and or maybe you don't have any of them, then you can acquire those skills, but then you'll have to put a lot of effort in that. People who are from the electronic side and software side, I would say you should all try your hands with robotics as well. It's really niche, and it's going to be a skill of the future. All people today would eventually have a lot of people using these skills to be deployed in the market. You all know, so many students are passing out every year. How do you see your career? If your career has to progress, then you need jobs in the market, right? There would be limitations. That limitation can be overcome if you have skills like these. Think of it, yeah, all those who may not be remembering, but even today, how many mobile repairing shops do you see around you? Every nook and corner of the country would have some mechanic who is making a living out of repairing a mobile, right? And trust me, most of the engineers which come out of our colleges, they would not be able to typically repair a mobile phone the way those people are able to do. What happened was that those people, they took the skill of repairing a mobile by using, uh, getting into this whole stream. They started and they explored, and they became conversant with the way mobiles are repaired, which you would not have the skills at. So that is an acquired skill. If those undergraduates, they can do those kinds of things, you can do much better. And given that, tomorrow you will have so many of these robots available everywhere. Now you have robots in houses which are doing mopping, right? Now these mopping robots and all things which would be there, even on your security guard place, you would have some kind of a robot. Even your boom barrier would be lifted by some kind of a robot. Probably your car would be autonomous. All these devices and the robotic structures which would go in life coming in the future, would they not need services? Would they not need repairing? Would they not need modifications, upgrades, accessories applied to them? There's a huge potential of employment in this sector. So should you have any one, two, three of these skill sets, or you have inclination towards it, I would say you should get into robotics. That's a very, very important aspect, and this is going to rise, and it can make you self-sustaining as well. So first, let us talk. I talked about the three things, but if you look at the mechanical part of it, it is typically related to how a robot's mechanics would work. So depending on how big the robot is, how does it look, what is it made up of? So material science would also come partially into it. But this also requires a lot of CAD designing and prototyping. So I would want all mechanical engineers, if you have not done that kind of a skill, take that skill now. Given the 3D printers which are accessible to everyone, and if not, you can get those 3D things printed in the market because job work is available. So if you can use your CAD skills, design robots, that's in itself a huge, huge potential area. People are looking for engineers who can design, ingeniously different kinds of robots. Many of you would have seen robots from Boston Dynamics, right? The walking robots, quadrupeds. You've seen bipeds, you've seen humanoids. And Boston Dynamics is one of the leaders in the world. Those robots, every day, people are coming up with new and newer inventions and ideas, they need a structure to be given to them. And that's where the mechanics come into part. And that's where you see a lot of potential for yourself. It is not necessary that you build the entire robot, but even the part of building it physically requires a lot of element of knowledge which has to be gained, right? The second aspect that which I talked of, electronics, how the motors have to be controlled, what controller to use, which kind of embedded controller to use, which kind of power supply has to be designed. So then you get into the aspect of PCB designing, prototyping, circuit design, component connecting, signal conditioning, modules. All these components come in so that you can sense the environment, you can execute the motions, and all these things, they constitute the electronic part of it. These are the skills which you would need and which can help you in the robot making. Third, as I said, the software part of it. Typically, Python, C++ are the primary languages which would come into play, but that's not limited. Different platforms also have various versions of native C and other kind of languages as well. Those can come into play, and that could give you a good idea of this thing. This is also to be superimposed with your skill set needed in the web technologies, because much of the control of a robot is now done over the internet itself. So IoT would become a primary criteria for robotics as well. So how do you start? So the best is to start with a simple kit. I mean, these kinds of kit, if you'll go and find on net, on Amazon.in, and you can go to robo.in. These robots are available for as low as 3,000 to 5,000 rupees. And they can give you much better perspective of exploring and having a hands-on idea of what can move, how it can be moved, and how do I control it. Then you have Udemy, Coursera, etc., and YouTube, Thingiverse. All these will give you a lot of projects which people have been doing and open source ideas on what you can do with this. This can get you going very fast, and you would seriously love to tinker around with these things. Once you have these kits, you work them once or twice, then you can, try to modify them. Okay, I will try to rotate it at a given place. Can I control how much of motion happens after a particular action happens or an event happens? So the moment I go in front of a wall, 20 centimeters from the wall, I should turn left, right? These would give you a lot of ideas which can actually help you start going into the robotics domain. A typical example, I'll tell you, I was grooming a group of students who were making some kind of a robotic endeavor, and they wanted certain robot to actually do obstacle avoidance. So the robot moves forward, it finds an obstacle, it's supposed to steers on the side and circle around that object. Now, how do you determine how large that object is? And what happened was the students just deployed a simple sensor for determining the distance. But that sensor does not tell you how wide the front object is. Maybe the whole wall is, in front of you, and there's no way around the wall. Then what do you do? So that's exactly these problems which will come into play the moment you will have these kits, and you will have a lot of idea of what can be done, and there are multiple ways to mitigate these problems. So buy these kits, get onto these courses which give you a good idea of robot operating system also. ROS takes away a lot of low-level functionalities which you would typically be programming, and that can give your robot a much more autonomous kind of a control. And what happens in the future? If you look at the future, then you see that the robots are going to become much, much more smarter. People are already building robots, and IBM recently built a robot which had almost 16 motors attached to a silicon layer, which would mimic a complete human face, and the skin would move to give expressions of smile, expressions of anger, expressions of despair, all like a human face. They even have cameras which are hidden behind optical lenses, which give a complete vision like a human eye, with eyelids blinking every now and then, with the expressions changing based on the accent. Even the accent changes. So all these things are happening, and humanoids may be the way forward. It depends on how industry progresses and how the needs arise. So what are the industries which are affected? I already told you earlier, health and medicine is becoming one of the most important uh, sort of a service area which needs robots. Can you do precision surgery? Can you do remote surgery? Can you take up the trivial task of transporting? All these things are much needed. And if robots are deployed, which can give a qualitative delivery on these things, it can save many, many lives. A very, very important domain which needs much of the robotic aspects. Then agriculture, again a huge area. Agriculture requires a lot of human, care, and a lot of manual effort goes in. If your farm is in acres, think of the effort the farmer has to do to maintain that farm. If we could give robots that whole structure, they could do it at a much lower labor cost. And that could probably have a lot of benefits also in accuracy. So again, agriculture, food industry, hospitality industry, all these have a lot of use cases. Transportation, another major area, and the whole world is now looking at, given the success of Tesla autonomous driving, you would see that this is now something which is phenomenally good. So you would have cars which would be autonomous, even flying cars are coming up, even drones are available. All these would need a lot of transportation which is completely autonomous or robotic in their behavior. How to program them, how to build them, how to maintain them, how to service them. All these would require a lot of manpower in these domains, which you have to skill upon. Even the defense sector. So how do you do recce for other areas? How do you do surveillance for military? How can you have a swarm which can attack and control or to do some kind of military activity? All requires robotic operations. The best drones, the Heron drones, completely autonomous, and they are typical UAVs which are completely autonomous. These are elements which have complete robotic systems built into them. So and Israel right now is working on swarm of Heron drones. That would typically be almost like a swarm of about 30 drones, which would be as effective as a fleet of 20, in fact, more effective than a fleet of 20 F-16s working in tandem. That kind of efficacy they are building with these kinds of automatic robot patrols. Here are some of my endeavors, which would probably help you understand. I'll just play this video. This is a replica which we have recently built at Maker's Lab. This is a Wall-E replica we have created, which has almost all the elements which was there in the movie Wall-E. This is just for the fun sake of it. But the use case that we are chasing with this is that this would have an empathy statement with our colleagues in Tech Mahindra, and this would be a wellness robot which would answer queries for people's wellness. Just play this video. So that's one of the use cases that we have been working upon. Another is where we are automating wheelchairs, and this would be autonomous. This is a wheelchair which we converted an existing wheelchair uh, being worked upon. The autonomous part is in progress, but again, a robotic endeavor as such. Okay, so that's some of our endeavors. There have been other use cases we are chasing. We are making a robotic arm which can play chess, and that would come as a CKD kit, and we would be distributing it across India, and that would probably give a lot of students across India the ability to actually have a feel of how robots can be built and learn in the whole process. So that's a use case we are chasing. We are also building a complete autonomous car, and which would probably be ferrying people around. Idea is for community driving, and we are first converting our existing golf cart into a autonomous vehicle. Eventually, it would be a kit which would be available. I'll come, Nasir. This is the last slide, and then we'll talk to you. So AI, ML, IoT, drones, AR, VR, and quantum computing is what we do at Makers Lab. A lot of domains that we chase upon. There's a plethora of activities we do at Makers Lab, and we can have a complete session separately on that, where we can tell you, and you people are all invited. Anyone who wishes to join with us, who wishes to work with us, is completely welcome. Just drop us a mail, and we can have you probably as interns in our Makers Lab at Tech Mahindra. Any questions? So I saw Nasir's hand. The forum is open, please. I would love to have more questions.
Yes, anyone who has any questions?
No, ma'am, no questions.
Okay.
Hello, sir.
Yeah.
Sir, I like to make a micro mouse. How to make it?
You want to make what?
Micro mouse.
Yeah, definitely. So what you can do is, if you go to Thingiverse, there's a project which is called, I don't remember exactly, but you'll have to search, and it is a cute robot, owl robot. So that will give you an idea, and you can transform this into a micro mouse kind of a robot, right? If I could, there's a small R2D2 over here. If you can see over there, that is a robot which we have recently built. So you can build it in the shape of a micro mouse as well. Details
Okay,
to join Makers Lab, it's very simple. Aditya has asked this question. So it's very simple. You just drop in a mail. Ganesh and everybody has my email ID. Just drop us a mail, give your credentials. We'll tell you the process. There are some small formalities which you get a letter from your college and all. Submit that, and then you become an intern for 3 to 6 months.
Yeah, sir. Okay, thank you.
The email ID is very simple, pankaj@techmahindra.com. Let me
Okay.
just type it here.
Excuse me, sir.
Yeah.
First of all, good afternoon, sir.
Yeah.
Yeah, sir. Actually, as we know that every coin has two sides.
Right.
Then the pros that you have been saying that this can be implemented in agriculture, defense, etc. But I would like to know somewhat about the cons of this robotics as well.
Like
Unemployment. Is it affect the unemployment of something like that?
so this is more of, this conversation would always be there. I remember in 1991 when I graduated, and I joined a company. So we started on a project for automating their process of advertisements in a newspaper industry. And there were about 30-40 people involved in that whole process to do daily billing, to verify the ads, publish them in the newspaper. All that process required about 30 to 40 people. And when I started working on it, people were really scared of us. They thought these IT people will take away jobs, because what we do as 30 people would be done by computers. And actually it did happen that whatever they were doing was earlier taking 30 people. This could be done in less than 5 people, actually speaking. We built that. So 25 people literally were supposed to be displaced. Supposed to be. And this threat was loud and clear written on the wall that yes, 5 people are doing the job what 30 people were doing. But eventually it never happened, because the moment this happened, the business started shooting up. When you were able to deliver the bills every day, earlier there would be a backlog of 1 month, 2 months on the billing side. Publish all those bills, handwritten bills were to be made every day, 500 bills to be made, 10 people just sitting making the bills, right, manually. That went away, and the computers were doing it in what, 1 hour, 2 hours. But then it created a complete department of 30 people for recoveries. So then there were people who would chase and go out and get the money. The bills are going on time now, somebody has to pay. So you have to probably send people. So a whole department, recovery department, which was only 2 people earlier, now had 30 people. So anything which comes up like this, my belief is technology, while it may displace one kind of a factor, there would be other domains and other businesses which would come up and which would give you a lot of relief. Technology does not displace completely the manpower. It would create more avenues as well.
Okay, sir. Thank you so much, sir, for your time.
Yeah. Any other question?
Yes, anyone, any questions? So we
The
can move
fees,
forward.
fees structure of your course, sir.
Which course?
Robotics. Sir.
We don't conduct course, Bacha. We typically would have you as interns. You'll work with us, and we'll put you on projects where you'll learn a lot. There's no fee for it.
Yeah, okay.
Yeah, you apply for internship, you work with us, and you learn on that. There's no fee for it.
Okay, so anyone else from the participant side?
Great. Thank you. Thank you, everyone. And thank you for the patient listening.
Yes, sir. Thank you so much for your time. And I think really it might help all the participants in the field of robotics, like what all you have explained to them.
Sure.
And they have got a good opportunity to join the Makers Club.
All right.
Yes,
Thank
sir,
you.
we have one question in the chat box. The location of the internship, Kunal Tajani.
So most of the internships, they are done at our Hinjewadi campus, but given the pandemic norms, a lot of projects are being done remotely from home as well. Occasionally, you may come to our labs once in a while and show us what you've done. But we can have remote things also. And in certain places, we are doing some projects with customers where you might even be required to go to those locations. We have lab in Hinjewadi. We also have one lab inside Defense Sector College of Military Engineering. It is at Dapodi. So this can be done. People who are outside Pune, we have a lab in Hyderabad, we have a lab in Chennai, we have a lab in Bangalore, and we have a lab in Delhi where also we can probably hire you or induct you.
Okay. I hope that you have got your answer.
So if you are from Nasik, you can work from home and occasionally travel, once in a month or so to showcase what you are doing. Yes, you will get certificates for this. Your internship is typically a complete internship. You will be given valid certificates that you have interned with us and you can use on your resume.
Okay. Any more questions from the participant side?
The internships are typically 3 to 6 months. We prefer people working longer with us. 3 months becomes slightly shorter, but we need at least 3 to 6 months. If you do a 6 month kind of an internship, it is very good.
Okay. I guess all the questions are done. Okay. Yes,
Okay,
sir.
thank you, organizers. Have a happy day.
Yes, sir. Happy Republic Day, sir, and thank you so much for joining us on this occasion. And
Thank
I
you.
hope that we'll have some sessions again.
Sure. Thank you.
Thank you so much, sir. Yes, participants, I know you are all waiting for this exercise. So yes, the results will be announced soon. Okay, so everyone, firstly, I will share a feedback link in the chat and all the social media links. So please to join that because the results will be declared on the social media platform also. So all of you join the Instagram, LinkedIn page, the YouTube pages also. So please, yes, I will put the link. Okay, I request all the participants to wait for 2 minutes. Till then, you can fill the feedback form. I have messaged the link in the chat box. Okay, the results will be announced now. And the selected participants, the selected teams will have a meeting day after tomorrow, that is 28th of January 2022. All the top 30 teams will have a meeting on that day, like what the further procedure for the final round will be. So, and the not selected part of the teams, all the webinar sessions will be continued for them. So you can always be connected and learn through our sessions. Yes, so the results will come up soon.
Okay, ma'am.
Okay, so the results will be announced on the YouTube live channel of Cerebrospark Innovations. The link is being provided in the chat of all the social media. So you can just join the YouTube live of Cerebrospark Innovations on at 4:30. And
Okay,
I hope
ma'am.
all the participants will be there. As you responded to the webinar so good. So I think I actually know that all the participants will be there on the YouTube live. So we will meet there on the YouTube live. You can leave this meeting, leave this webinar and join the YouTube live at 4:30. So you will get the results there. And all the best to all the participants. All have done a good job during this Sparkathon. And I hope that those who have given their hard work and 100%, they all get selected. And last and the best reminder that all the top 30 selected teams will have a meeting day after tomorrow on 28th of January 2022. The link, the timings will be provided to you through mails. So please be connected, stay tuned. The result will also be announced through Instagram post. If anyone fails to just attend the live, you can just see there, or you can see the YouTube video again. Yes, so meet you at the live session again. Thank you so much for attending the Sparkathon webinar series, #O2.
Okay, ma'am. Thank you, ma'am.